Now we are moving on to test 2.7. From this point on, we're using the image formatting testing interface. This is the processing side of the image formatting side of the system. So for that, I will open up the image formatting testing interface. So here we have, this image will contain the original image. This box here will then contain the extracted number plate, and this box here, hopefully the character. The buttons here are fairly self-explanatory. That will scroll through images. The extract number plate will extract the number plate, extract the characters, will extract the characters, and that will iterate through the characters. If we go back, test 2.7 is the isolation of the number plate from within the image. So that's the first part there, extract the number plate. This will be using a set of real-world images, mix of cars and backgrounds. So if we go to our images, we can see we've got some folders here. We'll be using extracting images, which has a collection of number plate images here. So if we go to this, you can see that that's the folder passed in there. And if we run that, the first image appears there. So we're going to be assessing how many of these it correctly extracts that number plate. These are just JPEG, which are then converted to bitmap images. Extract number plate, that's 1 correct. 2 out of 2. 3 out of 3. 4 out of 4. 5 out of 5. 6 out of 6. 7 out of 7. So there, that appears to have only captured half of the number plate. So that's 7 out of 8. That is incorrectly captured. That contains the whole number plate. 8 out of 9. We've had an error there again as well. So that's 8 out of 10. 10 out of 11. And 11 out of 13. No, sorry, it was 10 out of 12, 11 out of 13. And that concludes those there. We can see it successfully extracted the number plate from a collection of those images. Test 2.8 is a test with the erroneous and extreme data. These are just images that do not contain number plates, and it should be able to identify that there is no number plate in there and not return a value. Those were the 2 images seen at the end. Here there is no number plate. Number plate not found. Here there's no number plate. Number plate not found. Now on to test 2.9. This is the extraction of characters from a number plate image. So this will be using a set of data that can have their number plates extracted in accordance with test 2.7. We will try and extract the characters from those images. So this first image, we can extract the number plate. We will then try and extract the characters. And it appears to have successfully extracted all 7 characters, and obviously back to the start there. We appear to have an error there in which it's assumed this is a character. But if we continue on, we can see it's got the rest of those correct. We appear to have had an issue there where it's split that U into two separate characters. That was an invalid number plate extraction in the first place, so I will not process extract characters. There was a small issue near the end there. That was not a valid extraction to start with, so I'll not process it. So there was an issue with the O to start with that one. And that concludes that test. So now on to test 2.11. This will be testing the ANPR system as a whole. Before I go on to that, I would just like to show each of the elements that come together in the ANPR system, just give you a brief overview of that. So the idea is that we have the image formatting. We start with an original image in which the number plate can be extracted, and then the characters extracted from that. Those characters are then passed into the character recognition system, of which analyzes each of those characters in turn and produces an output. Each of those characters is then brought together to analyze the number plate. You can see that working here. So if we look at the test 2.11, this is just testing the effectiveness of the system to get as many of the 7 characters correct as it can do to produce an output. So if we run that, this will be using a combination of the first and second data sets that I showed you earlier, the generated ones and the ones in real world scenarios. So if we run that. So new image. There are 5 images here that have been generated using an online generator. They are still JPEG images. It's simply been done just for testing purposes to get more images that can be tested. The same processes apply. That image there, the yellow number plate will be extracted, those characters extracted, so on to produce the output. So we go back to the first image and run that. We can see it's got that correct, all 7 correct, and we can continue this going. It's 3 out of 3, 4 out of 4. Got 1 character wrong there, and there's no more left there. Now if we switch data set to the real world ones, so it will have to extract the number plate from this image and then the characters and subsequently pass them into the neural network. If we run that, we can see it's got that one correct, and continue this going. It's got that correct. You can see it's made 2 character errors there. You can see it's made 2 more character errors there. There are 3 character errors in this one. If you remember earlier in the previous test, that bolt was identified as a character, which is why you have that extra one at the start, but there are still many more errors in that image. There are 1, 2, 3, 4 errors there, and no more images. So in that test there, we saw it got 4 out of the 5 generated ones correct, and 2 out of the 7 fully correct, In the real world ones, that combines to 6 out of 12. Now moving on to the next test. This test will be very similar to the last one, but we'll be including the database correction feature. This feature says that if there are 2 or fewer errors between the identified number plate and a number plate in the database system, it will assume it to be a valid identification and will match that up. So if we run it again, we will load up the car park to view the cars that have entered and just check for correct validations. If we run that, it's got that correct, and we can see it's popped up there. Next one. Now that has incorrectly identified the 3 as a 4, but that's only one that's incorrect. So assuming that number plate exists in the database, which it does, it's matched that correctly there. So it's got 5 out of 5 of those generated number plates correct. If we switch datasets, this first one here, it's got that correct. There have been 2 errors made there, so assuming that number plate's in the database, it should be correctly entered there, which it has been. That's 8 correct in a row there. We ran that. There are 2 errors there, so assuming that exists in the database, which it does, it's been added there correctly. 9 correct. This one here, there are 3 errors in this number plate. So when we run that, there, it's been added but incorrectly. And if we move on to the next one there, that's 9 out of 10. That one had more errors as well. That's 9 out of 11. And this last one is 2 many errors as well, so that should appear incorrectly there. So looking there, that's 9 out of 12 number plates that have been correctly identified coming into the car park. So the next test is 2.13. This is a test of how the entry and exit times are added to the records when cars enter and leave the car park. If we run this again and switch to the real world dataset, that image has popped up. If we load up the car park, you can see that it's currently empty. So this car is going to enter, and that's going to be amended to it there. If we then click the run image exit and refresh that, you can see an exit time is added on there. We can do that again. So that one comes in, and that car comes in. Let's get back through. Let's say that car leaves first. You can see it entered, it left. There we go back around again. That car can then leave. This can then lead on to test 2.13, which is what occurs when the same vehicle is said to be entering the premise twice in a row, or said to be entering the premise before it's then been declared to have left. So this would occur if a car is sat by the camera may detect it twice and try to amend it to the database 2 times in a row. So let's say this car enters. We look in the car park. It's entered at 9:49 and no exit time has been added, so the system assumes it's still in the car park. If we then try and run that again, an error pops up saying car currently in car park, not added to database. If we run the exit time, that pops up there. The car is then free to enter the database again and leave again. If we just run that image as leaving, the database remains unchanged.